Okay, and welcome to lesson 4 of structures and bonding. These are the rules we've covered so far with the atom topic and then structures and bonding. So we went through the structure of an atom and how it all works. Protons are positive, electrons are negative. Then we did the fact that electrons are in shells. And then we did the fact that you have to fill up the shells. And then we did the most important rule here in red, number 9. Atoms want to have a full shell. And look, it's even animated with a thing swimming around it to help you draw attention to it's the most important rule. Wow. Oh, look, it's swimming up here. Then we went on to the fact that how do atoms get those full shells? And what we've dealt with so far is they could lose or gain electrons. They then become positive or negative, and those positives and negatives attract. And then that leads to the one type of bonding we've done so far. So, title for today's work is Sharing is Caring. You'll see why it's an appropriate title in a little while. One sec. That's better. So, it's an appropriate title because we're going to deal with sharing of electrons today. So, some quick questions to get you started. Pause now, write the question, fill in the answer, and then when you're ready, press unpause. Okay, so the number of protons is equal to the number of, I need a pen, there's one. Neutrons? No, that's what most people will put. The number of protons is equal to the number of electrons. And the way to remember it is, the positives and the negatives in an atom must be the same. A charged particle, so once an atom loses or gains electrons, is called an ion. A metal becomes positive and a non-metal, so that would be ionic for the type of bonding. Which subatomic particle orbits the nucleus? So the one that goes around the outside of the nucleus is the electron. And last one, ionic substances have high melting and boiling points because they're solids, and that was our giant crystal lattice. So there's the answers again. And so this is what we've done so far. We've done the fact that if you have a metal, metals like to give electrons away. And if you have a non-metal, non-metals like to take electrons. So we have this, one of them gives and becomes positive, one gains and becomes negative. Just like down here in the example, sodium wants to get rid of one, chlorine would like one, there it is, it's giving it away. That becomes positive, that becomes negative, and that was all ionic bonding. Every single time there is a metal and non-metal, and that's how you have to record it. Just being able to say metal and non-metal is ionic, metal and non-metal is ionic. You can't forget that, because that leads directly onto the next type of bonding. What if they both want to take? So here we have an example where we have a non-metal and a non-metal. Well, what could they do? Both the atoms are non-metals. This one needs electrons. This one needs electrons. So if they both need electrons, we haven't got that one to give it away like in the metal and the non-metal. So here's an example. This, need to change colour pen because it was on white. This is a hydrogen atom and this is a hydrogen atom. So let's see, how do they feel? Oh, I'm very, very unhappy. I only have one on my outside shell and I need two. And here's a hydrogen atom. Oh, I'm very unhappy. They've got the same voice because they're both from the same atoms. Different atoms have different voices, I think. I'm really unhappy too. I've only got one and I need two. So this one over here is saying it needs an electron. And this one over here is saying, I need an electron too. they look at each other and they think, hold on, we both need an electron, but we've both got one, but the other one needs it. So what there isn't here is one is not sacrificial. One doesn't say, oh, you have it, and I'll just go off and be even more upset. However, how about the two of them go very close to each other? In fact, overlapping the shell of electrons. And this hydrogen here and this hydrogen here, there's that one. There's this one. This one says, you can borrow my one electron if I can borrow yours. And the other one says, oh yes, please. And now if you look at it, if we try and count up this hydrogen's electrons, it's got one here and one here. Ah, it can count both of them. And this hydrogen, the one I'm just putting a blue circle around, thinks it's got two as well. So what we have now is we have some, oh, I'm much happier now, my shell is full. And I'm much happier too, my shell is full. Let's go round together holding electrons. Just like a boy and a girl might hold hands to make them happy, here we have two hydrogens holding each other's electrons. A pair of electrons is shared there. That is called, unfortunately, and this is the bit, it's not called a sharing bond. So we had ionic. The name for this, that is called a covalent bond. So could you draw that out as your first example? Remember, you start with atoms with a problem, the problem being that they don't have a full shell, and then you find the solution, and that's down here. That means whenever you see the formula of hydrogen, hydrogen is always written as, now I've lost my pen again, hydrogen is always written as H2. And the reason it's written as H2 is they go round in pairs just like that. Right, let's look at another example. Now in this case we've got hydrogen, and we better stick with the same thing. Now remember, hydrogen's voice is quite squeaky because it's hydrogen, like a bit like helium from balloons. Oh, I'm very unhappy. I need an electron to go into this shell to give me a full shell. I just need one. The oxygen, however, has 1, 2, 3, 4, 5, 6 already. Oxygen is absolutely distraught. I'm very, very unhappy. In fact, I don't see any happiness in the whole world. See, it's even more upset. And that's the reason, because to fill up that shell to get 8, I need 2. I'm so unhappy. Look how deep my frown is. I've even got frown lines on my forehead. And a tear dripping down my face. That's how unhappy I am. I need 2 electrons. So, what do we do? Can hydrogen and oxygen, because there's nothing here to give them electrons, there's no metals around, can hydrogen and oxygen actually come to some sort of sharing covalent deal? So let's put our oxygen down first. I'll just put an O in the middle. There's his first 2 electrons, 1, 2. And there, ooh, there are the 6 on the outside, 1, 2, 3, 4, 5, 6. And here's a hydrogen. And the hydrogen says, I need 1. I need 1. Sorry, wrong voice. The hydrogen was doing an oxygen impression. I need 1. So the hydrogen comes along and says, you can share one of mine and I can share one of yours. And there's the hydrogen. The hydrogen now is absolutely tickety-boo. However, look at the oxygen. If we go round and count, it had 6 and it's now borrowed 1, so it's got 7. So actually, at this stage, oxygen is a bit better off, but it's still not got a full shell. So I would like you to think, pause and just think what could happen next. Now, I'm thinking some of you paused and some of you didn't. Ah, we need another hydrogen. We need another hydrogen atom. And the other hydrogen can come along and go, ooh, bingo! That hydrogen has a full outer shell. And now oxygen. Let's go around and count them with a highlighter, because that's a good thing to do. It's got one borrowed there and one borrowed there. That's two borrowed. Plus it has 1, 2, 3, 4, 5. It's got 6 it started with, 2 borrowed ones, and oxygen now has a full outer shell. Surely, at some point in your life, you've wondered to yourself, H, and O. H2O. Now, you all know that's the formula of water. And now you know, why is it H2O? Ask your parents that. Just say to them, why is the formula of water H2O and not H3O? And if they say, I don't know, you can say, oxygen wants to get 2 electrons, so it shares with 2 hydrogens with covalent bonds. It won't share with 3, because that would ruin it. And then that will make you feel all smart and clever. Covalent bond. Here, hydrogen has a covalent bond to oxygen and a covalent bond to hydrogen. Like I said, H2O. That is the type of bonding in water. And I've deliberately done this. This is the bonding in water, like I've just drawn it, and this is the bonding in water, 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 and this is the bonding in water. It can be drawn in many different ways, in exam papers, in textbooks, on websites, so just be aware, it's exactly the same. What have we got every time? This line shows a covalent bond. It shows that it's sharing a pair of electrons. Here, there's the shared pair of electrons. Here, they're drawn as dots and crosses, which is a good way of showing that these crosses started with the hydrogen and the red dots started with the oxygen. And here they're just shown as overlapping dots on the line. There's loads of different ways of representing the same thing, but every single time it's a pair of electrons for a covalent bond. Right, we've got one other type to do before you're going to go and have a little go yourself. So, this case, we know now that I am very unhappy. Remember me, I'm oxygen, and I'm oxygen too, and I'm very unhappy. And I need 2, and I need 2. I want 2, I want 2. I want 2 because I've got 6, and I've got 6, and I need 8. Because remember, rule number 9, it has to have a full outer shell. So, what do we do? I need 2. I need 2. Well, this one over here is talking at the moment. Hold on, this one with a speech bubble coming out of his mouth. And he says, well, hydrogen shared 1 because he needed 1. And what actually happens is, here is an oxygen with 2 in its first shell. And here is an oxygen with 2 in its first shell. That's that one. That's that one. This one and this one overlap their shells, just as we've done in the last 2 examples. Now what I'm going to do is actually, I'm going to change my colour and I'm going to draw this oxygen's ones as red dots. It's got 1, 2, it had 6 in this shell, 1, 2, 3, 4. Now the other oxygen wanted 2, so it's going to lend 2 of its electrons to the other oxygen. Because in return, what it's asking for is, let's do these ones as blue. It had 6 in the next shell, 1, 2, 3, 4, 5, 6. Would you look at that? This one over here is now saying, whoopee, I've got a full outer shell. Whoopee, I've got a full outer shell too. Oh, the world is a wondrous place. See, we've made some lovely atoms happy. This, again, is called a covalent bond. They are sharing those electrons in the outside shell. Haven't you ever wondered why oxygen is always drawn as O2? And there's even a phone company called O2. Oxygens always go round in these pairs, O2. Right, the only difference is how you draw it. Here is an oxygen atom, O, and here is an oxygen atom, O, and instead of drawing one line between them, we show there's two pairs of electrons by drawing a double bond. So we call those single lines a single bond, and we call this a double bond. So again, that's a great example to have written down. Pause, make sure you've got that in your notes. You'll need it in a minute. And here's a worked example for you to pause on. It's just a chlorine here. Obviously unhappy. Chlorine sounds like this. Hello, I am very unhappy. I have 7. And this chlorine sounds the same. And look what they do. So make sure you can follow that one through. And help the chlorine. And then 3 definitions to put in your notes. We learned a while ago what an atom was and what a compound was, and now I'd like you to write down a definition of what a covalent bond is, and then include that in your notes you send to your teacher. And then what we're hoping is that you are now in a position where you can try these. So what are you going to do? You're going to do exactly the same as we've done in our examples today. Fluorine, you'll start. You'll go to fluorine and you'll say, look at it on the periodic table. Fluorine has 9 protons, therefore it's got 9 electrons. If it's got 9 electrons, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, which means it has 1, 2, 3, 4, 5, 6, 7 on its outside shell. You can straight away go, it needs 1. And the formula's there. So you're going to draw another fluorine that needs 1, and then you're going to draw them joined together. That should take you a couple of minutes, and you're going to get faster and faster and faster, and then send a picture of those drawn out to your teacher to get feedback on whether you've got the idea and you've got it right. Excellent. Thank you very much for listening.